Greetings from PMAS Academy of Science and Commerce. Department of Physics presents practicals. In this video, this is basically for a quick revision for upcoming laboratory examination 2024. In this video, we're gonna discuss about the figure of merit. The aim of this experiment is to determine the resistance of a galvanometer by half deflection method and to find its figure of merit. The principle behind this experiment is the deflection in a galvanometer is directly proportional to the current through the galvanometer. That is, I is equals to k theta, where k is called as the figure of merit. The formula used in this experiment is as follows. That is, figure of merit of a galvanometer k is equals to E divided by R plus G into theta, where E is the EMF of the cell and capital R is the resistance of the galvanometer and G is the galvanometer resistance and theta is the deflection of the galvanometer. And also in this experiment, we're gonna find the resistance of a galvanometer. That is, capital G is equals to R into S divided by R minus S, where R is the resistance of the galvanometer and S is the small resistance. The apparatus required for this experiments are the battery eliminator, resistance box that is capital R, key, small resistance box that is S, and another one key that is K2, and also that is a galvanometer. First of all, the negative terminal of the battery is connected to the resistance box of the one end, and other end of the resistance box is connected to plug key, and the other end of the plug key is again connected to the galvanometer. And the other end of the galvanometer is connected to the positive terminal of the battery, and that the same end of the galvanometer is again connected to the small resistance box, and the negative terminal of the galvanometer is connected to the other end of the key, and another end of key is connected to the small resistance box. The circuit diagram is as shown in the figure, where BA is the battery and K1 is the key 1 and K2 is the key 2 and G is the galvanometer and R and S are the resistance box. The observation is the EMF of the battery is 2 volts. In this experiment, first K1 should be closed and K2 should be open so that current is flown on the upper circuit. We have to take out the resistance from R for 30 divisions in the galvanometer. We get 3500. Now K2 is closed. Now the current divides equally. We have to take out the resistance from S such that deflection is half. That is, for 30, half is 50. If it comes, then it is noted down. The small resistance is S. In the same way, we have to take away for different trials. The tabular column is as follows. For deflection in 30, we have to take down 3500 and we get for the half deflection, the small resistance is 50. In the similar way, we have to take down the deflection for another 20 and 10 divisions. We get the corresponding resistance. And when we get from the formula of a G, that is RS divided by R minus S, and we take the mean of this experiment and we get the average of G is approximately equal to 50 ohms. And we also take the value of K, that is K is equals to E divided by R plus G into theta. And we noted down that the K value is approximately equal to 18.23 mu, that is 10 to the power of minus 6 ampere per division. Therefore, from this experiment, we can conclude that resistance of the galvanometer G is 50 ohms and the figure of merit of a galvanometer K is equals to 18.23 into 10 to the power of minus 6 ampere per division. I hope you understood this experiment and All the best for your examination. Thank you.